Has the new supply of bits and bytes come in? Looks like we got it on reasonably quick delivery here. Let's see if YouTube updates. Ah, it does. It appears as though we are live. Extremely delayed audio through YouTube sounds okay. Not that I can listen to that while I speak. That would be extremely confusing. Hello, good evening. My name is Ben. This is Stray Capacitance. My amateur radio call sign is Alpha Bravo 4 Echo November. And I did a stream earlier today working on this project trying to reverse engineer this Logitech trackball sensor out of the M570, the Logitech trackball, which is one of my favorite trackballs. Switch to the bench. And this is my own M570. Well worn, still works wonderfully. Actually, this one's new from not too long ago, a year or so. But I've gone from one to the next of these over the years, just as I wear them out, or started a job and I need a new one on the desk at the job, that kind of thing. And it's also a favorite of my brother-in-law, who needs some assistive technology these days. And I'm hoping to be able to adapt the sensor out of one of these trackballs into a pointing device for him. So to that end, this evening I'm working on reverse engineering that protocol if I can, which first involves finding the pinouts for it. So I've got on the bench under Pinhead, the probing station here, the motherboard out of the, I believe it's an M570. I really should check, but that would involve taking it out of the extremely delicate bed of needles that I've got probed into it at the moment, and I'd rather not have to do all those again. I'm sure I will have to at some point, but I'm putting that off as long as humanly possible. So I've got that, the motherboard bolted in. I've got the 10 pins out of the flat flex connector broken out, or I'm sorry, probed in with these acupuncture needles in this 3D printed test stand. And those run off through little silicon coated wires into this breadboard over here that you can just see. It's mostly in frame, which gets us to a flat flex breakout for the Logitech trackball sensor, and also lets me break those out again to the Analog Discovery 2. I actually don't need these wires anymore. Let's get those out of here. So since this afternoon, I've changed a few things. My big concern, let me get this O-scope probe out if I can do that without screwing everything up. Almost certainly not. Let's take a look. Let's see and tell if we screwed up pin 5, which is the one we care the most about right now. Sorry for the back of the head cam, which I presume you were getting. It looks like pin 5 is still on its pad, so that's good news. Has my video frozen? That would be interesting. Has my stream frozen? That would also be interesting. OBS appears to have stopped updating, but I can't tell what's going on for sure. What happens if we switch scenes here? And then switch back. Now we appear to be live. OBS decided to save you from the glorious view of my balding scalp. Very kind of it, really. So, I've removed the external power supply I was using, and now I'm using the Analog Discovery 2 for that. It lets me dial in the voltage a little easier, and it allows for a little faster iteration because everything's controlled through the computer. Kind of don't need to go hands off to tweak with anything. That also, I believe, has given me a better ground reference for the logic analyzer. So I think my signals are a little more believable now. This thing seems to run at around 1.8 to 2.1 volts. So the power into it, it's designed to run off a AA battery, 1.5 down to 1.2, something like that, depending on, alkalines or rechargeables or whatnot. So I'm giving it, I believe, 1.4, and that is getting buck boosted up to, well, boost converted. You can kind of see the big inductor on there. I'm going to need some kind of a pointy thing. Oh, what kind of a pointy thing shall we use? We'll go with a nice sharp knife. That should be good. So down in here, there's this big inductor that's part of the boosting circuitry for the power supply. So the board itself seems to mostly be running around 2 something, something like that. And I previously had the logic analyzer just kind of in its default configuration, and I suspect it was running probably 3.3 volt logic levels. So that means that it was seeing transitions where there were none, just as the voltage got drawn up and down on the far side of that big inductor. It probably was bouncing around a little bit. So signals that were previously noisy are now not, and several signals that looked constant previously now look interesting. So let's go to desktop, and I'm just going to switch you straight to the desktop. Sorry about the OBS. I should have been one step ahead here. There we go. So I've added back in the signals that I previously had removed. And so let's get these into a logical human order for your meat eyes. You're not at all scary meat eyes that you humans have. Totally normal eyes. Okay, so I had previously, before the previous stream, gotten rid of pins 1 and 2, and I believe 8, 9, and 10. I decided those weren't interesting. And I still somewhat agree with past me, but past me was also not correct. So pin 1 looks like a power supply rail. It's just high. Pin 10 looks like it's likely also a power supply rail. I see no signals now on pin 10. Pin 9 looks like a ground. Pin 8 looks like a ground, probably. Previously, I'd thought pin 2 was a ground, and I was incorrect. Pin 2 is extremely interesting. Pin 2 looks something like a clock. You can see here from the cursors that we're dealing with about a 16.6 millisecond period on it, and about a 75% duty cycle. It's high about 75% of that time, and then low for about a quarter of it. And this is pretty consistent, but not completely. You find one of the interesting spots. Here's one. Sometimes when the Mosey and Mizzo lines are going, the master in, slave out, and the master out, slave in, pardon me, a little bit of a coughing jag. Sometimes when it's going, pin 2 gets interesting. So it's doing stuff here. Now in this case, chip select is high, so we're not talking to the device in question, assuming once again that I've got chip select correct. But It's kind of interesting. The timing stays reasonably consistent here if you look at the cursors as our 16 millisecond window. That's reasonably constant with other more normal clock cycles. But it does get stretched a little. You can see I've got the first cursor on the leading edge here. We would expect it to come back up on this leading edge, but it doesn't. It starts doing clocky kind of things, faster clocky kind of things, I should say. And I've found other places in the trace where it does interesting clocky things while chip select is low. So I thought maybe I would fire up a second stream for the day and just kind of spend some time investigating and talking to myself. And if someone ever looks at this and can tell me all the stupid things I'm missing, I'm always curious to hear it. So I think we've got 1, 10, 9, and 8 now that I think we can remove. And let's go back to my annotations here. Clearly when I said pin 10 was not connected, I was not correct. This looks like another VCC line. Let's say there are no obvious traces on the board. There might be a buried via or something interesting in there, but I don't know. I'm going to have to buzz that one out. And unfortunately, buzzing it out means taking it out of pinhead over here, which means losing, I don't know, 15 or 20 minutes of fiddly work getting those pins in place. So I'll probably be faster next time, just because I'll know what I'm getting into a little bit, but I'm not relishing doing that again. So I'm trying to find other things I can learn before I take the setup apart. Pins 8 and 9 as ground, that seems reasonable. And I've updated my notes here a little bit to say, let's go, yeah, there's a, no, there, no, there's some button to just hide this area, but whatever, not important. I've updated my notes on 2 a little bit. So it looks like a 16.2 millisecond clock. Should be around 75% duty cycle, but has other activity. And I dropped some screenshots in here for future me of other things. So pin 2 doing clocky things, pin 2 doing something a little different here. Here it appears to be clocking when neither Mosey or Mizzo are doing things. And it's after the trackball has been chip selected and had data sent to it. Here's something else where it's doing just something a little weird. It's kind of mimicking the Mizzo line there. And it's almost doing what chip select's doing, which is also what Mizzo's doing. So not quite sure what's going on. I think where I'd like to start is to read a little bit more about SPI, because it seems like maybe that's what I'm missing. But looking at their description of serial clock, and looking back at pin 5 in this trace, and I'll do another one here in a second, but this trace showed no activity on pin 5 at all. It just gets pulled high and it sticks there. And that's so weird to me. It definitely buzzed out as going to the microcontroller, and it definitely buzzed out as the the pin over here, pin 17. Let's make sure I get the part number right. And let's search for the data sheet. That should be the one. Pin configurations, pin descriptions, no. There we go. So I believe, if I recall correctly, we're dealing with the 28-pin MLF pinout. It's not the PDIP for sure. I don't think I've got any good macro photography of this, but to my eyes, it looks like this one. I don't think it's the 32, but the pin configurations are very close regardless. Obviously, the ones with more pins have more pins, but they tend to keep things in the same general area. Of course, these pins are very tiny, very small. And so I may well have buzzed out the wrong thing, but I did think that pin 5 on the flat flex went to pin 17. I must be wrong about which version of the thing, or I'm wrong about many things. You know how that goes. 17. There we go. I'm sorry. This is the one, the 32 MLF, not the 28. I can tell by the orientation of where I think these pins are, I believe. So that one was actually reasonably easy to buzz out, as I recall, from back in November, right? Obviously, I was working under a microscope because it's like a 1/4 millimeter or a 1/2 millimeter pitch between these. And I should probably buzz them out again now that I've got Pinhead going, because the probing needles will make that a lot easier. It'll be a little bit tedious getting everything cycled up, but that would be a useful exercise, I think. But if that's PB5, SCLK, and PC int 5, so maybe it's not being used as a serial clock, maybe it's being used as an interrupt, but this microcontroller isn't incredibly adaptable. I don't know a lot about embedded software development, so take everything I say with a small truckload of salt. But the modern ARM cores seem to be extremely adaptable. They'll have like a crossbar arrangement inside almost, where any feature can be linked to any pin. Very dynamic, and for those of us who are reasonably new to things, very hard to understand. But these older Atmel chips in particular, aren't that way. These have like the serial, the SPI interface on board isn't configurable in that manner. So let's take a look at the SPI interface. Zoom you back out a little bit. So full duplex, of course, 3-wire synchronous data transfer. It can do any of the different, it can be either the master or the slave. It can do least significant byte first or most significant byte first. Of course it can. We can do double clock speed. So lots and lots of options and lots of things in the register. To step back for a second, another way to approach this would be to try to dump the firmware off the ATmega and reverse engineer that with, there are tools out there that I don't know much about. I know IDA's the expensive and highly regarded one. I've seen people use other things too. I'd have to do some research to figure out what reverse engineering software even speaks the AT Mega. I believe it's thumb code is what's used. But again, I'm out of my depth at that point. I've compiled for the AT Megas, but not gone deep on the actual binary interface and things like that. I just let the compiler deal with that for me. So, high, master and slave prepare the data to be sent to their respective shift registers, and the master generates the required clock pulses on serial clock line to interchange data. Data is always shifted from master to slave on the master out slave in MOSI line and from slave to master on the MISO line. After each packet, the master will synchronize the slave by pulling the slave select line high. So the master pulls the line low to signal that things are about to happen, that things are about to get interesting. The clock gets generated at that point, which I thought the clock was constant, but the clock is only necessary when there is a packet being interchanged. So we look here, if we ignore the kind of slower pulses here, right, which I don't know, there may be another item on this bus that I'm not aware of. Maybe it's the radio, which I'm again reasonably sure is SPI. But if we look here, and this is maybe a bad example, but master pulls this low, and then let's see, we don't see it clocking out the data there, which is what I would expect. Again, master pulls this low, but the clock is back here. Hope you can hear that wonderful Logitech scroll wheel action. I know that's what you're here for. This looks more like what I would expect if this was potentially serial clock. And again, we see nothing on pin 5 during this, but chip select goes low. We see some clocking here, and maybe my capture rate isn't fast enough. I'm kind of running up again near the limitations of the analog discovery, so I've turned things down a little bit, and maybe that's part of my problem. Once I get rid of some pins here, once I feel confident in the ones I can get rid of, maybe that will restore things a little bit. So maybe this is clocking the data in and out. Pin comes up the last time, things are restored, the final bit gets clocked out, and then the clock line's just held high. That might be what we're looking at. What I don't understand is what's going on, like here, it could be clocking to another peripheral, but I would expect to see something on the MOSI and MISO lines like we do in other places. So I'm not really sure what we're seeing. Let's see if I can find one of the places that's definitely not talking to our trackball. Nope, I'm not seeing it. And maybe I'm incorrect and there isn't anything else on this bus. Maybe the wireless controller has its own interface. Maybe it's I2C off other pins on the micro. I'm not sure. But actually, no. See here, chip select is high. This gets pulled low, which may just be it setting up the state for the clock, right? And then data is clearly being clocked in and out right here to another peripheral. And it's both Mosey and Mizzo. And again, I still haven't seen the trackball clock any data out. I have yet to see it do anything while what the line I believe to be chip select is low. So I suspect that I have problems with my setup. Maybe I've got a wire crossed. I did actually go through when I built Pinhead and label all the wires. So I hope that I did not do something boneheaded like wire the wrong green wire into pin 4. But I went with, kind of resistor color coding so that it was a little easier to tell things apart and keep the order straight. And one of the nice things about that is it means that like the first black wire is line 1, but then the second black wire is line 6. So they go on different sides of the board. They go far apart in the ordering. So I don't think I've screwed that up. I may well have perhaps one of my cables isn't well made. That's entirely possible. I did buzz them out, but I should have paid more attention to the actual resistance, because you can certainly have something that will pass the buzz test, but it's dropping. It's got 20 ohms across it or something, and with a high-speed signal like this, that's plenty of resistance to lose your data. At least I believe so. That's the kind of thing I've been told. So I'm going to declare pins 10, 9, 8, and 1 uninteresting. I'm going to keep 7 around for a little longer because I still don't trust it. Although when I did buzz it out in my notes, back to this, I said pin 7 just had a capacitor to ground. So maybe that's just a ground line. Well, but no, it's pulled high. Interesting. Oh, maybe that is VCC as well. Let's add that in. VCC. So many VCCs, all the VCCs. So that's a possibility, and maybe I can ignore him as well. But I'm starting to think pin 2 is the clock. So let's now hopefully boost this up to 0.5 megahertz and see if I can do another capture. And I'm going to reach in and wiggle the trackball around a little bit. 5 million. Okay. Let's pick a segment of interest here. Well, that's interesting. Here's something interesting. That is starting to look more like a clock. A little more regular. Lining up with data changes. If we accept that maybe this is all settling in there, right? And when the clock either goes high or low, that's when the data gets sampled. That's a thing we'd have to figure out, but curious about the clock rate-ish here. This looks a little more variable, and one of the things about SPI and these kinds of interfaces is that it can be variable. If if the master or the slave wants to do, I believe in SPI it's called clock stretching, it's allowed to do that. So we're looking at 40 microseconds here between these peaks. And then this one's a little longer, might be 80. There's another 40. That one's a little more, but not a lot. Down here it looks a little more regular. 40, 40, 40. This is starting to feel clock-like. So I wonder then, we can drop in an SPI configuration. If we say pin 6 is our chip select, pin 2 is our clock. Let's look at the MOSI pin. I don't know which direction we're going yet, and I don't know which way to sample the clock, but I figure if my theory is correct, that the trackball isn't speaking to the microcontroller and it's trying repeatedly to initialize it, which I think is still probably true, maybe. Then this may show us something. Okay, so that interaction there, again, was with the other chip. So that's not interesting particularly. Well, it is, but not for this. Let's see here where it's interacting with us. Select goes low, and then the clock comes in. It's interesting to me how seemingly unstable this clock is. Is it an exact mirror? Pardon me. I was looking at the data line there for my clock signal, and that is not so helpful. Zoom out further. Possibly interesting. Nope. I'm not sure quite what I'm missing. Interesting, but it's not sure. So the logic analyzer, the software, I should say, after looking at the data from the logic analyzer, thinks that it might have seen a 1, but it's a long way from sure. And let's just get rid of that abomination. There we go. We're programmers or pretending to be electrical engineers or something. We're not going to read decimal numbers. That sounds horrific. So, and in this situation here, the clock's not being helpful. It's got like 1 tick. So, I'm not entirely sure yet what I'm seeing here. The potentially interesting thing is going to be another question mark, isn't it? Yeah, it doesn't know what to do with this. It's got like not enough, no clocks in there, so it doesn't know what to make of it. So this clocking that I'm seeing might just be voltage level weirdness, kind of bumping back and forth over the course of a couple milliseconds, or microseconds, I should say. But the regularness that we saw in the one location looked suspicious to me. That felt like something. Let's take a look at the data sheet for the ATmega and see what its clock rates are. System clock and clock options. I'm vaguely aware that a lot of times the frequency range possible, especially on these small micros, is dependent on the voltage level. So this is all the wiring, and there is a crystal on here in a can. I cannot recall what it is. I can take a look at that a little later. Actually, it might be right up top. Let's take a look. So here's our operating voltages. 1.8 through 5.5 for the 168 PV and 2.7 through 5.5 for the 168. Now in my notes, what did I say? I said 168P, but I'm not sure that's completely accurate. Let's do a little macro photography. That sounds kind of fun. I'm afraid I can't take you along for the ride here, but I may be able to get a shot getting out my Sony camera. I'll put you back on the bench, and perhaps this will be interesting. Not that you'll be able to see again, but whatever. So I've got my Sony camera, and I'm going to try here by fiddling with the tripod to get a shot of the microcontroller. Preferably without taking everything apart. I apologize for that bump. It's bad of me. Okay. Putting some faith in my tripod right this second, which is not a thing I like doing. So I don't have a real macro lens for this camera. What I do have is a couple of macro extenders that change the focal length and let you use telephoto. And at that point, your distance to your subject basically becomes your zoom. So a combination of moving the camera down some here, I can avoid screwing everything up. That would be nice. Okay, I'm getting the right. Oh, I'm right at the limits here of what the zoom will allow. think that might come out. Give it a second to write to the SD card. We'll pull it out, drop it into the computer, and see what we've got. Recap the camera so I don't break all the things. Now we'll see if we've got some sweet, sweet images. I'm not even slightly a camera file, nor an audio file, nor anything else interesting like that. But I enjoy just about every hobby I've ever found, so I wind up accumulating a lot of equipment. Let us see what we can see here. No, you really don't need to start the schedule back up, but fine. DSIM, most recent. Give Shotwell a second to come up. That's not quite in focus. Let's try other ones. Focusing on the small screen. That one's not badly focused, but I can't quite read it. You can see the mega. You can see some either cat fur or old man hair. One of the two. Probably cat fur realistically. I don't have enough hair to leave behind all on electronics like this. This one. 168PA, it looks like. So where were we? PA or PB? No, definitely looks like an A to me. 158? I'm going to get out my monocle here. And again, thankfully OBS is not going to does say 168PA. Let's get that fur out of the way so I can be 100% sure, hopefully without screwing up all the things. Always good to take sharp tweezers to something. Yes, it's marked 168PA MU something 302. China stroke B 2X3501. Let's take some notes. I said, and I believe this was 305. Is that correct? You're all yelling at your screens. 302 MU 302. So let's see. Different data sheet. Oh, how interesting. Is this automotive? So perhaps my pinouts were wrong because I had the wrong part number. Automotive quality guide. How interesting. Logitech is using automotive parts. Kind of cool. So if we look again, pin 17, which I believe goes to pin 7 in my world, is still serial clock. And we go back to my notes. Pin 2, I didn't buzz out to any pins. That's clearly incorrect. That must have a processor pin. So can't decide if I want to sneeze or not. Interesting. So it's not a pinout problem, but I wonder if the SPI bus is slightly different. Pin functionality. So this is kind of that same timing diagram that Wikipedia gave us. Just kind of talking about the basics of SPI and these different modes, right? So we can sample on the leading edge, we can sample on the falling edge, we can do setup on the falling edge, or setup on the leading edge. Yeah. The best part of standards is that there are so many of them. So this is kind of nice. So modes 1 and 3 are kind of inverted of each other, right? Mode 1, the falling edge is what's important. Mode 3, the rising edge is what's important. It's just kind of whether the clock is default low or default high. And in mode 0 and mode 2 are kind of the inverse of each other. It's the leading edge, but rising or falling. Again, whether the clock is default low or default high. Interesting. That's down to the UART. Let's go CK. So that finds us. Ah, interesting. Alternate functions. So, well, is that when we were on? PB5, right? PB5 can be S clock here. It can also be an interrupt. So it's possible that pin 5, which I thought was clock, isn't being used that way and is instead it's being used as an interrupt. It's also entirely possible that they are bit banging SPI instead of using the hardware peripheral. So I shouldn't get too hung up on these pins because it's possible that they're doing everything by hand. And in that case, they can use any pin that they like. So interesting. So it really does become a question of, are they using the serial peripheral, the SPI peripheral built into the chip, or are they bit banging the protocol? And I don't know enough to know what is likely. Um, because it would make a lot of sense for the trackball to have an interrupt for the for data changing, right? Rather than having to pull it constantly, it would raise an interrupt to the microcontroller. The microcontroller would service the interrupt and then query the trackball for what data it had. So either one of those uses is completely reasonable. Um, and this would be great if I had the firmware and I could think about what values were in which registers and start looking at how things were configured. But that will be a different stream for sure. Because I am not set up in any way. I don't even know how to go about getting firmware out of an atmel. My guess is that, well, first of all, my guess is that Logitech is a competent enough company to have burned the fuses. So I probably can't pull the firmware out of the microcontroller easily. I know that there are very talented people, Micah Scott and Kate Temkin, who can do things like that. I am not one of those people, and I do not even aspire to be. It's good to know your limitations. Um, I'm sure I could learn it at great, cost of time and energy. I wonder if Logitech provides the firmware anywhere. 570 firmware update. Downloads. Show all downloads. We're definitely on Windows. Definitely on Windows. How nice. Hmm. So there's a firmware update tool here. If I had to guess, it probably pulls it over the internet. These are just the Microsoft Visual C runtimes, QuickTime stuff for their windowing library, Visual C Core Lib. There's nothing here that's obviously of interest. Now, platforms, Q windows, not sure what that is. An image format, that might be interesting. Or maybe that's literally like an image on the screen and it's just what they use to ship, the pictures of their devices. Because, of course, Logitech software never lets you forget how pretty their stuff is, and they always want you to know whose stuff you're using. So one possible route would be to go to Windows and run the firmware update tool and see if I can get it to update and on like my Logitech M570 and see if I could get it to pull the firmware update down, possibly with network sniffing or something like that, and get the bits that way, and then I could start reverse engineering that. Another option would be to try to sniff the connection between the radio and the micro during that process, which would, if Logitech has their act together, and again, they probably do, they may well have their bits encrypted, and they get decrypted on your PC, sent over the air, possibly even decrypted on device, but I'm guessing that's not likely with an ATmega 16AP. Yeah, very interesting. I'm tempted to go further down the hardware route before I go that way. It's certainly interesting, but and probably more productive if I'm honest. I'm certainly more of a software person, but part of the joy for me of this project is pushing myself to learn something a little different and dropping into a disassembler. I know I'll figure that out. Even though I'm not familiar with the hardware of the platform, it's just time. But I'm not really like learning a new skill at that point. I'm not sure. Another thing I could do that might be of interest would be to, rather than looking at pin 2 with the logic analyzer, which has a kind of limited resolution, right? It picks a voltage reference level, and if you go above that, your signal is high. If you're below that, your signal's low. And especially over a long wire with some impedance, like I've got here, that might be losing some information. Let's switch over to the bench cam. And maybe we'll try to get an oscilloscope probe on here without screwing everything up. And that second part will be the interesting bit. I had one on 5 earlier, because I still thought 5 was interesting. I'm not so sure about that anymore. Yep, screwed everything up. Very good. Very, very good. Tiberius is interested in coming back in, playing with Dad, but he'll have to wait for a little bit, because I am a monster. Okay, so that's got my probe onto the needle. Now I need to get the needle back onto the pin. This time you probably are going to get scalp cam. Sorry about your misfortune. Unsubscribe. All fine up until scalp cam. Unfortunately, as I believe I mentioned, getting these needles in where they belong is extremely fiddly. I believe I have that on pin 2. So let's switch back to waveforms here. Go to the scope. I'm on channel 1. I've got a 2-volt range here. Let's see what we've got. That's interesting. That looks like a noisy clock to me. Now a lot of that noise may be from my setup, right? I'm the one trying to probe this out. Let's do a single. Get some more cursors in here. So if I trace from one peak to the next, I'm looking at about, is it 40 microseconds? Yeah, we kind of are, aren't we? There's our 40 microseconds that we were seeing in the logic analyzer when we looked. Now, again, the analog discovery isn't the best at anything, but this is interesting in that you can probably let the speed go a little bit more. Let's run another signal here. That's a nice one. There we go. There's our 40 microsecond clock. Tick, tock, tick, tock. And here again, you can see it's a little stretched here. Not terribly, but a little bit. And a little stretched here. Now, unfortunately, I only get 2 scope channels. So I can't probe out the entire interface this way, but this is interesting. So interesting. I would love to see this overlaid with logic analyzer. I wonder if I can do that. Add custom. Oh, that's right. This thing has this scripting interface. Forgot about that. It's kind of cool. Let you do things like, math or other operations in there. Protocol decoding, I think. Now, I'm trying to recall. Yes. I think don't really know what I'm doing here, but I thought that there was a way to add scope signals in, or maybe they're just tied into these. I note that I've got these stars here now. Not quite sure what that means. Should read the directions, obviously. Where's the fun in that? So I'm definitely starting to believe pin 2 is my clock here. And like in this case, my problem is just that it's not chip selected. I wonder if I can turn chip select. Let's pretend. Imagine, if you will, that chip select is inverted. And now it's able to actually find some data. Now that's not actually correct, right? Because this peripheral has its own chip select line that's gone low, and everything up to that point is noise. But you can see that the protocol analyzer's like, oh, here's where a hex 07 started, and then it finished somewhere in here. And that's just because it's picking up this stuff, which any peripheral where its chip select or slave select line isn't low is going to ignore that as noise. So this may literally be noise that they haven't bothered to optimize out because all the peripherals are turned off, their slave select lines are high, and everything's fine. I'm not sure. This is very interesting though. So I think my next steps off camera, especially now that I've already botched some of my pinhead setup. When I went in there to put the scope probe on 2, I jostled a few other things around, including pin 3, which was the hardest one to get in place. So now that it's been moved, I'm kind of meh about the whole thing. I'm sure I'll have to redo it at some point, but in the meantime, it seems like as good a time as any to might as well do it on stream. Do it live, as they say. Just boop, 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 boop. Now, for the manual dexterity portion of the quiz, it's time to see if I can. I've got you on the wrong view. No, I've got you on the bench cam. Oh, I probably had you on the bench cam for far too long, including missing all the interesting scope data. I'll show you that in a second. So, my nut spinning would be unfortunate. So that one comes out okay. So the holders here, the person who put together the design recommended, let's turn that power supply off, just for giggles, recommended wing nuts, but I decided that that would be a little too fiddly in a setup like this. So I went with just M5 captive, M5 cap screws. Now that will hopefully let me pull this out. And now is once again when I wish for a bigger bench. Let's see how foul this looks. Oh, my bench cam is frozen up again. That's important to know. Okay, let's go back to the desktop for a second. Let me show you the waveforms I was seeing that you were not. So there's my 40 millisecond clock on pin 2. So that's interesting. So I wonder, let's swap out my trusty, somewhat dusty multimeter probe for something nice and sharp with good stabbing potential. I like leaving the little mini grabbers on when I can, because it's way easier for me to leave them grabbed onto something, but that won't be good enough for this. So let's see if bench cam updates now. Yes, okay. So I've got something wrong with my bench cam setup, and it goes AWOL after a bit. Fair enough. Good to know. Am I in shot at all? Not really. As Big Clive would say, one moment please, while I shift all this around to try to get us someplace to work. There we go. Okay. So let's see now. I'm going to grab my dental loops. These are extremely handy. A lot of people have seen or used little plastic loops like this. This one's my 7x magnifier, but the focal distance on these is extremely difficult. So I was at the dentist a while back, and she was working away on my teeth, and I noticed she was wearing a pair of these. And these are 3.5 times, if you can see that there. But the focal distance is 420 millimeters. So you can actually work out several inches away from your face and still get the appropriate magnification. In fact, you have to. And they're binocular. So I find these to be quite useful. Interesting. This might require some serious macro photography here to figure out what's going on, especially with my bodged up solder job there. But one. Pin 5 definitely buzzes out for pin 17 on the microcontroller. Again, doesn't mean it's the serial clock. I'll be darned if that's not suspicious. conductive debris there, as Micah Scott would say. Grab my trusty, never-mouthed toothbrush for that. Here, now you can see a little more clearly, although possibly not very clearly, the microcontroller down there in the shadow of that capacitor. There's your big inductor as part of the power supply circuitry that's all kind of over here. And there on the bottom, there is the networking chip, and you can kind of see the antenna running out there around the edge, I presume. There's no copper on the top in that area, which certainly suggests them leaving that area open for radiation. And it is an NRF chip, if I remember correctly. I need more light than that. It is a NRF 24L01 plus. And the final numbers is 1221BP, presumably a date code. I'm going to guess the 21st week of 2012. And here, just one last thing before I maybe start wrapping up. Here you can see again the test points on the bottom. So maybe that would be a good place to start, would be the test points. And flip the board over and kind of go through the same process. Probe out those test points. See what's going on there. I do think I definitely have a little work to do with figuring out where pin 2 goes. And that is going to definitely require some minute macro photography. I'll probably get out I'll probably drop many things off the other bench and get out my little vise here. Flip him over. Actually, word choices all the way around. There we go. That'll work best, I think. So if I take this, find one of the few flat edges on this thing, can't imagine how much board space they waste to get the ergonomic shape on this. As a user, I appreciate it, but as a frequent purchaser, I wonder how much cheaper it would be if it were a little more square. There we go. So that will probably let me get some good shots of the connector and surrounding traces, hopefully. Maybe I can figure out where pin 2 goes. But at any rate, the cat is starting to beat on the door, and I think I am close to wrapping up. As always, if anyone knows anything about this product and can tell me something about it, something I don't know, or knows all the things that I'm doing wrong, has good advice on what I'm missing about the SPI clocks, or how the pins are configured on a Atmega 168PA, or knows that nobody ever uses the serial clock peripheral and everybody does their own bit bang, or has a data sheet for the sensor would be ideal. I could just short circuit the whole project. I would love to hear from you. Please leave a comment and I will get back to you. Otherwise, I hope you all have a pleasant evening. Get a bunch of work done on your own projects, or just chill and enjoy your cat or person or solitude, whatever you prefer. And with that, I think I'm going to wrap it up. Have a good evening.